What are all the parameters we should consider for forging design? In designing a forging, the following points should be considered. First point is the forged component should be able to achieve a radial flow of grains or fibers. The second consideration is the forging which are likely to carry flash, such as drop forging or press forging, should have preferably a parting line in such a way that the same will divide them into two equal halves. The next consideration is the parting line of the forging should be as far as possible in one plane. Another consideration is sufficient draft on surfaces should be provided to facilitate easy removal of forging from the dies. Another consideration is the sharp corners should be always avoided in order to prevent concentration of stress and to facilitate ease of forging. Then the pockets and recesses in forging should be minimum in order to avoid increased die wear, and ribs should not be high and thin. Last consideration is too thin sections should be avoided to facilitate easy flow of metal. Another topic on this manufacturing is mechanical working of metals. The mechanical working of metals is defined as an intentional deformation of metals plastically under the action of externally applied forces. The mechanical working of metal is described as hot working and cold working, depending upon whether the metal is worked above or below the recrystallization temperature. The metal is subjected to mechanical working for the following purposes. First one is to reduce the original block or ingot into dished shapes. Second one is to refine the grain size. And third one is to control the direction of flow lines. First we will see hot working. The hot working metals above the recrystallization temperature is called generally hot working. This temperature should not be very high to reach a solid temperature, otherwise the metal will burn and become unsuitable for use. The hot working of metal has many advantages. First advantage is the porosity of the metal is largely eliminated. Then the grain structure of the metal is refined. The impurities like slag are squeezed into fibers and distributed throughout the metal. And the mechanical properties such as toughness, ductility, percentage elongation, percentage reduction in area, and resistance to shock and vibration are improved due to the refinement of grains. Hot working has some disadvantages also. It requires expensive tools. It produces a poor surface finish due to the rapid oxidation and scale formation on the metal surface. And due to the poor surface finish, close tolerances cannot be maintained. Next, we will see some hot working processes. First one is hot rolling. The hot rolling process is the most rapid method of converting large sections into dished shape. It consists of passing the hot ingot through two rolls rotating in opposite directions at the same speed. The space between the rolls is adjusted to conform to the dished thickness of the rolled section. The rolls squeeze the passing ingot to reduce its cross section and increase its length. The forming of bars, plates, sheets, rails, angles, I-beam, and other structural sections are made by hot rolling. Next, we are going to see hot forging. It consists of heating the metal to plastic state and then pressure is applied to form it into dished shape and size. The pressure applied in this is not continuous as far as hot rolling, but it is intermittent. The pressure may be applied by hand hammer, power hammer, or by forging machines. The next type of hot working is called hot spinning. It consists of heating the metal to forging temperature and then forming it into dished shape on a spinning lathe. The parts of a circular cross section which are symmetrical about the axis of rotation are made by this process. Another hot working process is hot extrusion. It consists of pressing a metal inside a chamber to force it out by a high pressure through an orifice, which is shaped to provide the desired form of the finished part. Most commercial metals and their alloys such as steel, copper, aluminum, nickel are directly extruded at elevated temperature. The rods, tubes, structural shapes, flooring strips, and lead covered cables are the typical products of extrusion. Next, we are going to see hot drawing or cupping. It is mostly used for production of thick-walled seamless tubes and cylinders. It is usually performed in two stages. First stage consists of drawing a cup out of a hot circular plate with the help of a die and punch. The second stage consists of reheating the drawn cup and drawing it further to the desired length having the required wall thickness. The second drawing operation is performed through a number of dies which are arranged in a descending order of their diameter so that the reduction of wall thickness is gradual in various stages. Next process is called hot piercing. This process is used for manufacture of seamless tubes in its operation. The heated cylindrical billets of steel are passed between two conical shaped rolls operating in the same direction. A mandrel is provided between these tools which assist in piercing and control the size of the hole. The billet is forced to outlet. Next we are going to see cold working. The working of metal below their recrystallization temperature is known as cold working. Most of the cold working processes are performed at room temperature. The cold working distorts the grain structure and it does not provide an appreciable reduction in size. It requires much higher pressure than hot working. The extent to which metal can be cold worked depends upon its ductility. So, if metal is having higher ductility, the more it can be cold worked. During cold working, severe stresses are known as residual stresses are set up. Since the presence of these stresses are undesirable, a suitable heat treatment may be employed to neutralize the effect of these stresses. The cold working is usually used as a finishing operation, following shaping of metal by hot working. It also increases tensile strength, yield strength, and hardness of the steel, but it lowers ductility. The increase in hardness is due to cold working is called work hardening. Cold working produces following effects. The stresses are set up in the metal, which remain in the metal unless they are removed by subsequent heat treatment. The distortion of grain structure is created. The strength and hardness of the metal are increased with their corresponding loss in ductility. The recrystallization temperature for steel is increased. The surface finish is improved. The close dimension tolerances can be maintained. What are the different cold working processes? First one is called cold rolling. It is generally employed for bars of all shapes, rods, sheets, strips. In order to provide a smooth and bright surface finish, it is also used to finish hot rolled components to close tolerances and improve their toughness and hardness. The hot rolled articles are first immersed in acid to remove scale and washed in water and then dried. This process of cleaning the articles is known as pickling. These cleaned articles are then passed through rolling mills. The rolling mills are similar to that used in hot rolling. Next cold working process is called cold forging. It is also called swagging. During the method of cold working, the metal is allowed to flow in some predetermined shape according to the design of dies by a compressive force or impact. It is widely used for forming ductile metals. There are three commonly used cold forging processes. One is sizing, second one is cold heading, third one is rotary swagging. Next cold working process is called cold spinning. This process of spinning is similar to the hot spinning except that the metal is worked at room temperature. The process of cold spinning is best suited for aluminum and other soft metals. The commonly used spun articles out of aluminum and its alloy are processing kettles, cooking utensils, liquid containers, and light reflectors, etc. The next cold working process is called cold extrusion. The principle of cold extrusion is exactly similar to the hot extrusion. Most common cold extrusion process is impact extrusion. The operation of cold extrusion is performed with the help of a punch and die. The work material is placed in position into a die and then struck from top by a punch operating at a very high pressure and speed. The metal flows up along the surface of the punch, forming a cup-shaped component. When the punch is moving up, compressed air is used to separate the component from the punch. The thickness of the sidewall is determined by amount of clearance between the punch and line. Next operation is called cold drawing. It is generally employed for bars, rods, and wires. In cold drawing, different processes are there. First one is bar and rod drawing. Second is wire drawing. Third one is tube drawing. Next cold working process is called cold bending. The bars, wires, tubes, structural shapes, and the sheet metal may be bent by many shapes in cold condition through the dies. The stretching of the metal outside the makes shock thinner. Usually, a flat strip of metal is bent by roll forming. Next cold working process is called cold peening. This process is used for improving the fatigue resistance of the metal by setting up compressive stresses in the surface. This is done by blasting or hurling of a rain of small shot at high velocity against the surface to be peened. Shot peening is done by air blast or by some mechanical means. As the shot strikes, small indentations are produced, causing a slight plastic flow of the surface of the metal to a depth of a few hundreds of a centimeter. The stretching of outer fiber is assisted by those underneath, which lend to the original length, thus producing an outer layer having a compressive stretch, while those below they are under tension. The surface is slightly hardened and strengthened by cold working operation.